Hello everyone, this is Jay Wingro and welcome to Think Like a Software Engineer, Episode 5. There's more to programming than just simply getting your code to work. Without a deeper understanding of what the computer is doing with your code, you can end up writing code that is either really slow or perhaps takes up way too much memory. So, one of the key things that the software engineer understands is how the computer actually processes your code. And a subset of that is specifically how the computer interacts with data. You may be familiar with the concept of an array. If not, an array is simply a list of things. If we want to say it in a fancy way, we can say that an array is a list of data, that is, a list of information. Here we have an array that contains 5 different kinds of fruits or vegetables: apples, bananas, cucumbers, dates, and elderberries. This array is a list of data. It's a list of this information. Now you'll see how I've labeled each cell within this array as having an index. An index is the official jargon for a spot within an array. Now arrays in most programming languages begin at index 0. So the first item in an array is index 0. In this case, apples is within index 0. Bananas is at index 1, namely the second spot within the array. Cucumbers at index 2, and so on and so forth. Now, a key thing to understand is that a computer is not a human being, and therefore, a computer doesn't act like a human being. If I asked you, which cell, which index within the array is the dates at, you would immediately just look at this array and immediately spot the dates and tell me that the dates are located at index 3. However, a computer doesn't have eyeballs. So how does a computer actually answer that question? So a computer has to begin at the first cell and work its way through all the subsequent cells looking for the dates until it finds it. So first, the computer will check the first index, index 0, and look for dates. Here it sees apples, so it moves on. So in the next step, the computer looks at index 1, again looking for the dates, but only finding bananas. In the third step, it looks at index 2, finding cucumbers, and in the fourth step, it finds the dates at index 3. So I have a question for you. What is the maximum number of steps that searching for something can take on an array? So in this example array, where there are 5 things, the maximum number of steps would be 5. Because let's say we're searching for elderberries. It would take the computer 5 whole steps until it finds them, because it would start at index 0, and after 5 steps eventually find elderberries, because again, a computer cannot look at something with eyeballs and has to just analyze one cell at a time. Likewise, if the computer was looking for figs, which is not contained within this array, it would take it 5 whole steps searching through each cell in the array in order to eventually determine that, hey, figs aren't actually within this array. If we want to say it in a fancy way, we can say that the maximum number of steps that searching for something can take in an array of size n is n steps. So the size of an array is simply the number of items within it. So for an array that has 5 things in it, the maximum number of steps for search would be 5. If the array had 100 things in it, the maximum number of steps it would take to find something within that array is 100. So for any array that has n items in it, it could take up to n steps to find something. If you're finding either the last item in the array or looking for something that's not in the array at all. Now, let's go back to our array. And let's say we wanted to ask the computer a different question. Instead of asking for a particular fruit, we're going to ask, what is at index 3? What is at the 4th spot in the array? That's a different question. And that's called reading from an array. So searching from an array is looking for a particular item within it, looking for dates. Reading from an array is asking the computer, what is at index 3? or what is at index 0. How many steps does that take? So the software engineer understands how a computer works under the hood and understands that reading from an array of any size only takes a single step. Why is that? I thought the computer doesn't have eyeballs. It has to do things sequentially. So this gets to understanding how a computer's memory works under the hood. In a very simple sense, looking at the right-hand side here, a computer's memory is divided into little itty-bitty cells. Each of these cells has an address, similar to your home address. Every memory cell has an address. So I've just chosen example addresses. So the first cell in your memory may be address 1000. The next one is 1001 and 1002, etc. But you can imagine that your computer's memory is a whole bunch of cells, and it stores one piece of information, one piece of data within each cell. When you create an array with your programming language, what you are doing is, if you look on the left-hand side here, you're basically taking a set of contiguous, that is, you're taking a bunch of cells in a row and saying, I want this to be my array. So if I want to have an array of 5 things, I'm finding some 5 empty cells in a row and saying, this is going to be my array. For each item in my array, I'm going to store each item in one of these cells. Now, another thing to note is that a computer has the ability to go to any particular memory address in a single step. If I ask the computer to go to memory address 1099, it can do that. It doesn't have to do that sequentially. Why? Because that is simply how computers are built. Therefore, let's look at our example array again. So here we have our apples, bananas, cucumbers, dates, and elderberries. And as you can see, each index is actually corresponding to a particular memory address within your computer's system. So if I asked the computer, what is at index 2? Another thing the computer also knows, and this is just something that you know because I'm teaching it to you, a computer also knows the beginning memory address for a particular array. So the computer knows that my array starts, in this example, at, say, memory address 1010. So if I ask the computer, tell me what's at index 2, the computer just has to do some simple math. It says, well, I know that this array begins at memory address 1010, so that's going to correspond to index 0. You're asking me to find what's at index 2. That is going to be 2 memory address spaces away from the starting one of 1010. So 1010 plus 2 is 1012. And since a computer can go directly to any memory address without passing go, the computer can immediately jump to memory address 1012 and answer my question that cucumbers is what is located within index 2. Similarly, if I ask the computer what's at index 4, it says, well, the memory address of the beginning of this array of index 0 is at 1010. You're asking me what's at index 4. That's going to be 1010 plus 4. So that's memory address 1014. And the computer can jump immediately to memory address 1014, look it up and tell me, hey, elderberries is what is stored at memory address 1014, which happens to be index 4. So simply understanding the basics, the fundamentals of how the computer interacts with data will eventually allow you to write stronger, more efficient code. There's nothing particularly complex about it. It's just knowing and learning about how a computer works, and this is important knowledge for the software engineer. Thank you for joining me today, and I look forward to seeing you again next week.